excited to, oh, and there's the recording in progress. In case you're just joining us, we will be recording. So happy to have folks join us here. This has been a meeting that's been a long time in the making, and many people have worked very hard on it. I will call them out a little bit later, but for right now, my name's Debbie Franco, and I have been, let's see, what would I describe my role as? Perhaps troublemaker and shepherd of this LiDAR team effort that's part of the California Water Data Consortium. A while back, as the organization was just coming together, I noticed that there was opportunity in this LiDAR space around promoting collaboration. And so with the grace of the board of directors at the time, I started this project. And I didn't even calculate how long ago that was. We were going to do like a quick turnaround, like 3 months, and we were going to do an event and be done. It's been much longer than that, but all for good reasons, because there's so much activity in this space and so much opportunity. So thank you so much all for joining us. The purpose of this particular meeting is to build our understanding of the needs and support around that would enable cross-sector collaboration and information exchange, specifically when it comes to derived products. So how do you take all of that raw data and turn it into something that's useful information? And you know, people have been doing that for a long time, but how do we do that in a way that creates common information for people who might be making decisions in the same places or about the same topics? And how do we assure that folks who can't otherwise access LiDAR information are brought into the circle and also able to access data that will help them to do their work too? We'll be, in the course of this meeting, gathering information about the challenges you're facing with LiDAR derived information, and we'll talk about how we might be able to help each other. I'm going to hand it over for just a second. Initially I said, Tara, can you do a Reader's Digest version of what the consortium is? But instead she's going to do the Twitter version. So I just want to say you can visit the webpage to get more information. But for a very short second, I'm going to hand it off to Tara Moran, who's our executive director or CEO. Actually, I should know that. Tara?
Thank you, Debbie. And yeah, thank you all for being here. I'm Tara Moran, CEO of the California Water Data Consortium. Really excited to have you all here today. Just as a very brief background on the consortium, during California's last drought, it was just really clear that both state and local agencies didn't have the information that they needed to make well-informed water management decisions. And so in response to that need, the legislature passed the Open and Transparent Water Data Act, commonly referred to as AB 1755. And the consortium really spun out of part of the articulated need within that legislation of state and non-state partnership. And we're really seeing that reflected in this meeting here today. And so the goal of the consortium is, in partnership with the state implementing agencies, to really ensure that data are useful, that they inform critical water management decisions, and that they can be accessed. And so this meeting just really epitomizes that, our mission and all of that. So really thankful to have you all here today, and for the team that's worked so tirelessly to pull this all together.
Thank you, Tara. And you may see Amanda adding comments, and she is Tara's fearless partner. So just to introduce her quickly too, you'll see her. She's the technical person, so she may be in the back. Oh, and there she is, waving at everyone if you can see her. Thank you, Amanda. So the idea behind this LiDAR team that was created is ultimately to see if we can cultivate catalyze what the consortium can do to bring folks together and help them. Are there ways that we can provide information that helps to increase opportunity for collaboration? And so ultimately this team is headed toward a larger meeting that will be it coordinated and aligned with state activities that are moving toward a strategic plan for LiDAR for the state. But as we were going along, it seemed like there was a strategic opportunity to capitalize on activities the state was already engaged in, really focused on forest and shrublands and understanding the needs in that sector. And you know, we're the Water Data Consortium, so we're really interested in water. But what we really realized is that there was an opportunity to bring people together across sectors and try to organize both across sectors and within geographies. So that's really where we're headed today, is to help you all connect with each other, to generate some information that that we will push back out to the group for your use. I mean, the success of all of this depends on all of you rolling up your sleeves and both absorbing the information and reaching out to other folks as that's appropriate, giving us feedback, and really just continuing to grow this community of folks who are connected to each other working on LiDAR data collection and use. You all, some of you, many of you may know about a state instigated meeting that happened on March 17th, that again was focused on forest and shrubland. And so I'm going to hand it over to Nate from the Department of Conservation, who was really the driver. I'm sure you all actually know Nate. He needs no introduction. And he's going to share a little bit about how this effort is related to the effort the state undertook a while back.
Thank you for the introduction, Debbie. It's a pleasure to see all of you here. I wanted to take a moment to make sure that we're understanding where the various pieces fit in together, and to reassure you that this meeting is not a direct overlap of the one that I conducted. That one was much more narrowly focused around forest and shrubland issues, and in particular around some funding that the Natural Resources Agency received in last year's budget, specific to wildland and wildland fire related remote sensing, with a strong emphasis on forest and shrubland, with some of that funding being devoted to the collection of LiDAR. And now we're taking a really good look at what sets of derived products we should consider producing from some of that newer and other recent high quality publicly available LiDAR, to put data in the form of derived products that's immediately useful for folks working in the wildland fire sort of genre and overlapping areas into people's hands, so they can be immediately useful. I'm happy to note, if it hasn't been circulated otherwise, the state has committed almost $4 million of that funding to a set of 2 partnerships, most of which were actually launched by folks outside of the state, to collect LiDAR for approximately 46,000 square miles of the state, so close, somewhere around a quarter of the state's area. And we're really looking forward to seeing that data land and seeing the derived products that can be built from it, both as part of our program as well as the great work that everybody else will certainly be doing with it. So thank you, and back to the rest of the agenda.
Hi, everyone. It's now my opportunity to share a little background and orientation for you all. My name is Ariel Ambrewster, and I'm a facilitator with CSU Sacramento's Consensus and Collaboration Program. And I will just orient you a little bit. And this should be right. Can everybody see my slide? Yep. Sounds good. Yes. Great. Okay. So as Debbie mentioned, we've got Debbie and Amanda and also Tara here from the consortium. And here is Amanda's contact information. If there are any technical issues that you all encounter, you can email or Zoom chat her to get some help. And then just going over our agenda for today. So our first part of the meeting is focused on backgrounding you first on LiDAR derived products. So we will have Mark Tuckman from Tuckman Geospatial, and Tim Bailey from the Watershed Research and Training Center, who will offer some orientation information to you about LiDAR derived products. And then we will turn to framing our work today, a couple examples of some really successful regional collaborations that have occurred around LiDAR derived products. First, from Steve Steinberg from Los Angeles County and Lariac, and then once again from Mark Tuckman and the work that's been going on in the North Coast and the Bay Area. So that will take us to around 9:55. That sounds rather specific, 10-ish. And then we will bring everyone in to do, we'll have one set of in-meeting surveys. First, to help you all let us know where you want to go for your breakouts, and then a focused survey on the challenges that you all are experiencing that are driving your interest in LiDAR derived products. And the information that you generate in that survey is going to help you all get to know each other in your breakouts. So we'll produce an Airtable with that data. And then the second part of the meeting will be in breakouts. First, we'll organize breakouts by topic area of interest. And we'll have a couple questions in each breakout. And then you'll go in, we'll have a break, a 10-minute break. And then you'll get to gather by region. And we're going to encourage statewide folks. There are a lot of statewide folks. If you are able to, we'd appreciate if you're able to sort of populate some of those more geographically focused breakouts to help support the regions with their work. And then we'll regather briefly and get you up at noon. And so with that, we will be using a, let me just get this link here. We will be using Mural today, and I am going to put a link here in the.
I think I put it for you, Ariel.
Thanks, Amanda. Amanda is wonderfully speedy. So, so that is a link to our mural board. And just briefly, so we've got about 86 folks here today. Of the folks who RSVP'd, we've introduced you. That's what I wanted to do. Team members. If we could have our consortium LiDAR team members show themselves on video and just wave to folks. Our LiDAR team members have really helped incredibly in working to get this meeting together. So we will have a LiDAR team member in each of the breakout groups, at least one member. And so that's part of who's in the room today. And then I just wanted to, as far as this is the data from our RSVPs, we asked folks how familiar you are with LiDAR derived products, and just wanted to show you that we have quite a mix of 23% were really technical folks who were highly familiar with LiDAR derived products, 12% none, 24% low familiarity, and then the bulk sort of with medium familiarity. So that was what we learned from our folks who registered, but we also wanted to ask that question of folks who are in the room today. And we're going to use a mural. I don't know if folks are familiar with mural, but we're going to ask that question again on the mural board that Amanda has shared the link out to. And I'm going to turn it over to Amanda to give a brief introduction to how mural works for those of you who haven't used it. And sure. I will stop sharing screen. Go ahead.
All right, I'm just going to go ahead and share. All right, this is going to be really brief for those who have not used Mural before. In the bottom very right-hand corner is the controls to how you can sort of zoom in and out. There's a little plus and minus. So if you use that, you can sort of zoom in or out of the board.
And just checking, can folks see Amanda's screen?
Good question.
Yes.
Great.
Okay. Great. And then below the little zoom in and zoom out, you also have what looks to be a map of the whole board. So you have a little square that's gray that you can sort of drag around to navigate to different corners of the board. And for this activity right now, we're going to be in sort of the top left where it says welcome. In this particular activity and in all of the spaces in Mural board, to create a new sticky note, you need to double click in the space. This particular spot is a little tricky, kind of need to do it at the top. And if you can't, go ahead and grab one of the circles that's already populated. And if you click once, you can go ahead and type in your name and your organization, and then drag it from left to right, depending on how familiar you are with LiDAR. All right, I'm going to pause there. And Ariel, I think you have a little bit more of an explanation to share. Oh, Ariel, you're on mute.
Are people seeing my presentation slide again?
Not yet.
There we are. Now are
Yes.
we? There we go. Okay, so the question on the mural is, how familiar are you with LiDAR derived products? And this is an opportunity to do a sticky with your name, organization, whatever you'd like to do. And we noticed with the mural board, to double click to create a sticky, you pretty much need to do it on the welcome. How familiar are you? Sorry about that, went too far forward. And for some reason, double clicking doesn't work on that line, but basically, so we have a continuum, and on one side, very familiar, on the left, on the right side, not familiar. And as you go into Mural, you'll click on Enter as a Visitor at the beginning, and then there's an example of the stickies. And if you want to just place yourself on that continuum by double clicking, as I said, on the title. And we'll spend a few minutes, and some folks are very familiar with apps, others not so much. So Amanda and I are here to answer any questions. If folks have any questions, if you want to type anything in chat, and we're here to help. So once again, if there's any questions, anything odd happening with Mural, as I'd mentioned, we found for some reason that double clicking on this little section was not always so easy. But if you go up to the welcome, how familiar are you with LiDAR, you can double click and create a sticky. Or if you double click on somebody else's sticky, it'll let you create one. So this is great. It looks like we do have quite a few technical folks here, and then some less familiar folks. So we're definitely trying to orient the meeting so that it works for everyone, and appreciate everyone having that understanding. With that, Well, I see folks are still working on here. I think I'm going to let folks continue to populate that, and let's move on to our first presentation. I want to introduce Mark Tuckman from Tuckman Geospatial, and he will start out our LiDAR educational backgrounding presentation.
Thanks, Ariel. Can folks hear me and see my screen? All right, great. It's great to be here. Thanks for having me. And I'm just going to give a really quick overview of LiDAR and some LiDAR derivatives and derivative products. So here's a quick outline of my talk. First, I'll just define at a really high level what LiDAR is and show what it is, and then go through some of these use cases, how LiDAR helps with topographic mapping, hydrologic and built area mapping, showing the derivatives and the data products, how it's useful and necessary in fine scale vegetation mapping, for forest health and forest management mapping, and then for mapping wildfire impacts and fuels. And after the break, I'll speak about number 3 and 4, the LiDAR users and uses, and the regional examples of LiDAR programs. So what is LiDAR, right? We're today talking about airborne LiDAR, not terrestrial LiDAR, but airborne LiDAR collected by an airplane carrying a laser scanner and shooting pulses of laser light to the ground. And those pulses of light are reflected back to the scanner. And for each point, the X, Y, and Z location is recorded. And what you end up with is an image that, like what you see in the middle of the screen, the point cloud, which is this giant cloud of points, each one again with its elevation. And it represents the surface of the earth, the buildings and the ground and the vegetation in this very precise 3D point cloud. And it's important to note, and the third image on the right shows it, that in vegetation, the laser pulse will have multiple returns. And you can see it illustrated in that image on the right with the first return from a top branch and a second, third, and fourth return from lower branches, and then the final return from that solid ground surface. So this is just LiDAR. This is we could spend the rest of the morning talking about this, but in a nutshell. And then let's talk about the sort of improved topography, hydrology, and built area mapping that we get from the LiDAR data. This slide shows a hillshade derived from quality level 2 LiDAR in the middle, and a hillshade derived from quality level 1, which is the highest ranking of quality by USGS on the right. And you can see how the LiDAR really sort of brings the landscape into focus. This is a hillshade, so it's showing bare earth topography. And you can see the roads, even the roads under the canopy, because the LiDAR is penetrating the vegetation. You can see the morphology of the streams and tributaries of the streams. And you can see the lay of the land, the convexities and the concavities really clearly. This is an example of a national hydrography data set stream centerline before we had LiDAR. So this is not derived from LiDAR. And you can see how that centerline doesn't quite, with much precision, depict the centerline. When we derive stream centerlines from the LiDAR data, we get really nice, accurate thalwags that nail the stream centerline. So this is a great improvement in mapping hydrography and hydrology. Here's another data product, Riparian, functional Riparian mapping or Riparian zone mapping. This is a LiDAR derived riparian zone map in Sonoma County. You can see the floodplains in green, the top of bank in red, the channels in blue. And this is, again, a big improvement on making this data without LiDAR. And this functional riparian zone mapping relies on a derivative called height above river. And this is an example of that derivative. And height above river provides information about the elevation above the nearest stream center line, not the elevation above sea level, but above the nearest stream center line. So how high is a pixel in relation to the nearest stream? And in this image, the red areas are those that are closest in elevation to the stream, and the yellows and blues are the areas that are the furthest in elevation from the stream center, the nearest stream center line. And this derivative, which we create from the point cloud, is instrumental in creating these riparian zone maps. Another important data product used that requires LiDAR is impervious surfaces maps. And those maps we developed from imagery and LiDAR, and they require LiDAR derivatives to make. Building footprints are a key input to the impervious surfaces mapping, and those are derived straight from the point cloud. You can see the building footprints in this slide in orange. And also necessary to create these impervious surfaces maps is LiDAR intensity. We do a lot of vegetation mapping across California. The simplest vegetation map we create it's called enhanced life form. And here's an example of the enhanced life form map across Santa Clara County. The enhanced life form vegetation mapping requires two LiDAR derivatives: canopy height, or the canopy height model, and canopy cover. And this is an example of the canopy height model. Each pixel represents the height above ground of the vegetation. And you can see here in this example, the greens are the tallest trees. And the canopy height model gives a quite accurate depiction at high resolution of vegetation height. And it's a critical input to mapping vegetation, to mapping fuels. A second derivative, really useful for vegetation mapping, is simply canopy cover. Where are the areas that are above a certain height, where vegetation is above a certain height? This image shows areas where vegetation is greater than 15 feet tall. So this is another important derivative in vegetation and fuels mapping. And here's an example of the enhanced life form map. And you can see the classes that we're mapping at this kind of coarse floristic scale are conifer, evergreen hardwood, native shrub, and developed. We also make much more floristically detailed vegetation maps, where instead of mapping forest or evergreen hardwood, we're mapping to the alliance. So redwood, coast live oak, Douglas fir, valley oak. And these more floristically detailed vegetation maps require additional LiDAR-derived inputs: canopy density, canopy volume profiles, slope, and aspect. And here's a schematic example of what canopy density is. We're looking at the percentage of returns that are greater than 15 feet. Canopy volume profiles give you even more detail, breaking the forest into multiple stratum and providing the percentage of returns in each of the stratum. This shows, for example, in this area, 35% of the returns are between 0 and 10 feet, and only 5% of returns are between 40 and 50 feet. Other important derivatives that are used for mapping fine scale vegetation: slope and aspect. which direction is the landscape facing, the aspect, how steep is the landscape, the slope, and LiDAR gives us that information precisely and at a fine scale. And here's an example of the fine scale vegetation map for the same area that I showed the enhanced life form. And you can see the vegetation types that we're mapping here are much more detailed. Instead of shrubland, for example, we're mapping baccharis, and forest is broken up into multiple classes. Let's talk for a couple minutes about derivatives useful for forest health and forest management applications. I'm going to just show a couple: tree approximate objects and canopy gaps and canopy height change. So tree approximate objects are derived by taking a canopy height model, which I showed earlier, and running algorithms to map each of the trees. Realistically, we're mapping small groups of trees, but this derivative is really useful for tree-based analysis, for looking at carbon and timber stocks, and for individual or small group tree species classification. Another important derivative for forest health and forest management is canopy gap mapping and canopy height change. And these derivatives are important for mapping outbreaks of pests or mortality from drought, or also from fire or from management. And this derivative, or these derivatives, mapping these gaps and the changes in canopy height, require 2 snapshots in time of LiDAR data. So I'm going to show an example here. This is Bolinas Ridge in Marin County. And this image that you're looking at is from 2010. And those trees on the south side of the image in the meadow were removed. They're Douglas firs that were removed in a treatment. They're invading the meadow. And this is the image in 2019. So you can see the trees are gone. But using the pre and post activity LiDAR to create maps, we can really accurately map the loss of canopy height and the formation of those gaps. And this is completely automated once 2 dates of LiDAR are in your hands. It's a really useful way of looking at changes in forest structure on the landscape. And lastly, and I'm almost done here because I know we need to move fast, using LiDAR derivatives to map wildfire impacts and to map fuels. I'm going to give 3 examples: ladder fuels, wildland fuel mapping, and then wildfire hazard mapping. And ladder fuels are derivative from the point cloud. It's a proxy for ladder fuels, looking at the density of vegetation in that 1 to 4 meter above ground strata. That strata where vegetation can carry a ground fire up into the canopy. And this map on the right shows the ladder fuels, which are high in white, overlaid with building footprints and roads. And when you start to look at those data sets together, it starts to help plan locations for treatments in the WUI. Wildland fuels maps. Wildland fuels maps are developed from several LiDAR derivatives and from imagery. And they're useful in modeling fire behavior and mapping wildfire hazard. And this is the sort of logic model at a simple level for what the inputs are to the fuel models that we're creating. So we're using the enhanced life form map that I showed before, LiDAR derived canopy cover, the ladder fuel proxy from the point cloud, vegetation height from the point cloud, and taking those inputs, doing a crosswalk to a Scott and Bergen fuel model that's typically 5-meter resolution. And then that fuel model becomes an input to the fire behavior models like FlamMap. And we use the fire behavior modeling to do things like create relative hazard maps. This is an example from Santa Clara County we're just actually in the process of completing under a contract that is mostly funded by CAL FIRE. So, and these are being used by the CAL FIRE, by the county folks who are working on the CWPP update, and for all manner of sort of where to prioritize treatments, where to prioritize hardening. And it's sort of a up-to-date and more resolute version of the CAL FIRE very high severity zones that are older and based on sort of less resolute information. So I'm going to stop there. I'll come back to this slide when I talk again in a little while. So let me stop sharing.
Mark, thanks so much. That was really helpful. Now we'll move on to our second orientation education speaker, Tim Bailey, from the Watershed Research and Training Center over in North Coast. Go ahead, Tim.
Hi, everyone. Can you see my screen?
Yep.
Yes.
Yes.
Okay. Good morning, everyone. I'm Tim Bailey with Watershed Research and Training Center. And that was a great launch, Mark. So we're focused today on airborne LiDAR. There's a couple of specifics about airborne LiDAR that are distinct from the other flavors of LiDAR, but in particular, its use as the basically our best available data set for large scale infrastructure mapping and natural resource mapping for a very large number of user stories. So we have to, the qualities of LiDAR are really built on the characteristics of the laser scan. These are highly redundant data sets in that omissions of individual points are not really a problem. There, as Mark alluded to, there are multiple returns per pulse in a variety of circumstances. And then it also captures variable intensity per pulse. The data sets are very large and growing, and we have to develop strategies to manage the large data sets and also strategies to manage inclusion of smaller data sets that will be like project-based LiDAR as well. So the other thing that I want to emphasize is that the characteristics of our LiDAR data sets are continuing to evolve as the technology and the market changes. I look at several generations of LiDAR within the last decade as having significant incremental improvement in the data sets. And that's something that we have to evaluate as we bring in and ingest new data sets. There's actually new capabilities that are present within the data sets. So the larger story of this is that the majority of our LiDAR is coming from this line scan pattern where we have a plane flying over territory and it's scanning back and forth. There are a couple of other LiDAR systems that are on the market that are available, and as they become more mature, we'll be adapting to those as well. So we look at this as having four major trees of analysis. There's high resolution raster methods, which are interpolating kind of small numbers of points and getting the highest resolution, like DEMs, digital surface models, and canopy height models. And then there's low resolution raster methods, which are sampling large numbers of data sets and grouping them into what ends up operationally significant units. And then there's the third category is point-based classification, which we'll go into. And there's basically each point is assigned to a category, and then we can use a logic model to integrate it into our data system. And there are specific categories that are built into the LAS standard, which I'll go into in a minute. And the fourth category is, vector object methods, where we are often trying to extract information about something we already know about, like a building footprint or road. In Mark's example of the NHD example, we already know a lot about streams, and we want to have we want to upgrade the mapping of that vector object. But there are a huge number of versions of this strategy. Okay, so the anatomy of a LAS file. LAS is our kind of default standard, and I've included LAS format 7 in this example because this is also the pattern that's used in photogrammetry, or that has merged color. But basically there's two units. There's a header and a point data record. And the point data record is basically a giant spreadsheet with X, Y, Z locations of points. And then it also has intensity, return number, number of returns, and classification flags, and classification. And these are the kind of logical tools that we can operate on individual points. The headers just give us metadata and material that we can kind of consider the whole block together on. So this is an example of advanced classification. In the bottom left, so the USGS, when they fund LiDAR, they have a base level specification which provides for classification of the ground, unclassified, water, and I believe bridge decks. We can increase the level of classification significantly. In the lower left case, there's building footprints are basically appended to the points, or the building class is appended to each point. And in the upper right corner, these are examples of power line classifications that are actually using different classifiers. And these are relevant for a lot of wildland issues. But these are just examples of the numerous classes. Now, so these are this table I've put in here. These are the reserved classes that are within the LAS standard, but you can also use other classes. You can write your own data dictionaries for other classes. So the other thing is intensity. So the beam returns have spectral value, essentially. One thing is that it is not necessarily standard that the intensities will be calibrated, but within regions of typically the intensity will have value. But like in this case, you can see the intensity is actually returning the line work on the highway, and you can actually see gradations of age of asphalt in this example. There are tons of other applications for using intensity, and particularly for snag mapping in wildland areas, or post-fire burn, or differentiating between leaves and the stems of trees. But you can also get spectral value to differentiate species potentially, but that's you'd want to have ancillary data as well for that. So this is like kind of a little look at a quick take on high resolution raster methods. On the left is a red relief image map, which allows us to visualize the channel morphology a little in some of the surface morphology. The center image is a simple canopy height model with the thresholds applied. And on the right is basically an application of a watershed function that was straight out of a standard GIS procedure for segmenting points in the data set. And so this is basically segmenting to individual trees, and that starts to provide us with demographic information. And so this is the simplest scenario of extracting tree demography from a point cloud data set. Now, the recent LAS standard allows us to write extra dimensions, and in this case, both these examples are writing height above ground into the LAS file. So these are direct visualizations of the point cloud, and you can see distribution of height above ground in the rendered in the colors. So we use a similar approach as Mark with tree approximate objects. So we use the extra dimensions capacity in the LAS file to write unique tree IDs that are extracted from a top of canopy filter. And then we segment to, these on the right, you can see these are convex holes that encircle every unique tree in the data set. And then we basically attach statistics from, in this case, we use, we're developing 60 different variables from the collection of points that are assigned to each tree ID. So this gives us information on distribution of sizes of trees and also the compactness of their spacing. And then this is an example of a scenario where this is using a photogrammetric point cloud, which is highly complementary to the large public LiDAR data sets, where basically we're doing a project-based, this is a project-based surveillance where we're generating a complementary point cloud to get the similar approach to the change detection that that Mark alluded to near the end of his presentation. And so this example is from the phase 3 experiment at Casper Creek, where they have a level they had a 2017 QL1 LiDAR in advance. And then in, I believe this is 2018 or 2020, they did a post-treatment survey of about, I think the full survey was about 400 acres, but this is a manner in which a project-based point cloud acquisition can support can be supported by the large scale watershed-wide collections that were that USGS and the state have been working on. And then this is where I think that a major technical move forward is currently there are streaming platforms available for the 40 trillion points that USGS has collected are available as a streaming service on Amazon through the Entwine point tile format. These can be streamed directly to GIS platforms. There are WebGL and other visualization tools to directly access point clouds without having to download them first. But I think that the Entwine point tile is likely to be deprecated in favor of the cloud optimized point cloud, which is going to really improve the performance of at-rest range reading of LiDAR data sets. And these are really built on the same strategies that have dramatically enabled the cloud optimized GeoTIFF to enhance our capacity to do remote sensing from cloud-based services like Google Earth Engine, the Microsoft Planetary Computer, NASA's various cloud optimized GeoTIFF servers. And this basically is leaving this groundwork for federating data sets with these large collections. And currently USGS point cloud is being, there's a process to load it onto the Microsoft Planetary Computer. Now there's currently support for COP-C with cesium, and there's been support for Potri and cesium for the Entwine point tile for several years. So these are vehicles which make it feasible for organizations to avoid downloading whole data sets or downloading bigger data sets than the analyst is expecting to use. And hopefully it will provide methods for us to be able to add annotations to the point cloud data sets that will improve their performance for our organizations. All right, thank you.
Great, thanks, Tim. And we will move to our examples from the community, examples of collaborations that have developed. So I will turn to Dr. Steve Steinberg from LA County. Go ahead, Steve.
All right, well, thank you for the quick intro. Let me get my screen share going here. And thank you.
Go ahead.
Should be sharing. So, and yeah, and thanks to Mark and Tim for the good technical overview. You must have been well trained. I'm going to talk more about the collaboration side. So we'll take all the technical stuff out of this part. So again, I'm Steve Steinberg. I am the Geospatial Information Officer for the County of Los Angeles down here in SoCal. And I'm going to talk to you just a little bit about how our consortium, the Lariac Consortium, has addressed collection of data. Aerial photography was the genesis of the Lariac program many years ago, but LiDAR came into the program more recently, and it'll be continuing forward. So let's go ahead and get started. And I'll just mention through my slides, you'll see some different sites around LA County. I'm not giving prizes, but you can keep track if you can identify the locations as we go. Okay. So just a little brief history. Before Lariac, so this would be going back, 15 plus years, there was a different model. Lariac came into play a little bit later. But LA County, if you don't know, is fairly large, a little over 4,000 square miles. The county itself, of course, is responsible for the unincorporated lands across the region. And there's some 35 plus departments, depending on how you count them and when, across the county that are doing their various roles, as all local governments do. We have 88 incorporated cities, and then hundreds, literally, of other jurisdictional entities representing a whole host of different things, from water and sanitation districts to transportation and shipping and so on. What this meant historically, before we created Lariac, was all of these different entities, when they needed data, aerial survey type data, they did it on their own. It was a free for all, which was a lot of time, a lot of effort from different entities doing their contracting. Great for the vendors because they had lots of potential contracts, but not so great from a data consistency perspective, because there was no consistency between jurisdictions, and certainly from a cost perspective also, everybody was spending a lot of what I'd call overhead on developing RFPs and contracts and management of those contracts for their individual jurisdictions. So with that problem sort of identified, of everybody getting their own data, my predecessor, who many of you may know, Mark Greninger, conceptualized the idea of Lariac. And the idea was, instead of everyone doing their own data specs, their own proposals, their own contracting, which really led to a big patchwork of different incompatible data sets at different scales, different times, different resolutions, different band combinations and so on. Mark saw this opportunity to bring entities together into a collaborative model where we could do this consistently across the county once instead of 100 times or whatever it may have been. So that's where Lariac kind of got conceived in the early part of the 2000s. Lariac 1, the first iteration that happened in 2006, obviously there was planning ahead of time. In the first iteration, over 50 partners, which was predominantly, again, the county, a number of cities, and a few other governmental entities in transportation and planning, and a few universities as well, came together and developed the idea of a consistent set of specifications and deliverables for the project. And that, of course, went through development and editing and review. But the idea was that everybody could come up with an agreement around a baseline set of data acquisition and data products that they could agree to. And in doing so, of course, they could pool individual agency resources into that single consortium, and then have one entity, in this case LA County, serve as the contracting body and the fiscal agent. So in essence, each member of the consortium is putting money into this common pool, and then each cycle the group decides what are we going to do. And you can see here that Lariac, we're currently in our 6th cycle, at least in the more recent times. After we got into Lariac 2 and beyond, the cycles run 3 years. So we typically do a primary data acquisition in year 1, and then derived products roll out in sometimes in years 2 or 3, and then we repeat the process again the following 3-year cycle. In Lariac 4, that was the first time there was a LiDAR flight, and I'll touch a little bit more on that later. But you can also see we're intending to do another LiDAR data acquisition in Lariac 7, which begins in 2023. And just to give you a little bit of a sense of, what the evolution of Lariac has been over the years, you can see it's varied in the number of partners, 50 in the initial iteration, and then it's gone sort of down and up over time. I think one of the interesting points here you can see is in Lariac 4, that was the highest number of partners, and for one big reason, that was a LiDAR year. That was a year that there were going to be derived products, such as you've just seen from our prior speakers, that would really be of additional value. So a lot more partners came on board in that particular cycle, and additional cities, additional universities, and so on. You can also sort of see the ups and downs of the budget, again, related to what was being done in a given cycle. But I think generally speaking, you could say there has been cost savings, both because of the partnership to individual entities over individual contracts, but also in general terms, a decrease in the cost of a given product over time. Technology improves, costs go down, those types of things. Some of those variations are also just the volume of products obtained in a given cycle. So just to highlight some of the benefits of what we've seen in these first 6 iterations of Lariac, certainly the cost savings is a huge motivator for everybody involved. We're seeing significant savings on the hard costs of the data acquisition and delivery of product, again, because we're working with a single vendor over all 4,000 square miles instead of 100 entities each doing smaller chunks individually. I think about aerial survey, the cost of getting planes and pilots in the air, it's sort of just as expensive if you're flying 100 square miles to get a plane up in the air initially. You got to bring it in, you got to fuel it up, you got to pay people to be in the area while they're flying. Those hard costs are kind of at some level, you get a volume discount when you're doing more at once. And then huge savings on overhead costs, because now instead of every entity doing their own bidding and contracting and fiscal management, we have one entity doing that for everybody. So a lot of staff time saved. In the first 2 cycles, where it was sort of easier to compare to the before and after, they estimated an overall across the consortium savings of about $10 million across all the entities. So significant numbers. The other thing we've been able to do with the consortium is even out the payment schedule for the members. So in a 3-year cycle, each member pays half of their fee for their participation in year 1 and half in year 2. They kind of get a pass in year 3, but we're flexible for our members if they need to do equal thirds. Some want to pay it all at once at the beginning because they have a bolus of money or something like that. But it definitely is easier than one entity having to come up with all the money for their own contract each time. The other thing we've really been able to do that's important in Lariac, and this is more on the photo side, but plays to the LiDAR too, is really push for higher quality data, better spatial accuracy, better resolution, and in part that's because we do an independent QA/QC. Our air photo vendor or our data collection is not QA/QC exclusively by the vendor, but also by another third party to ensure it meets our specifications and quality. Lets us share a lot of our technical knowledge across the consortium, especially beneficial for the smaller jurisdictions that may only have 0 or 1 geospatial person on staff, and they don't necessarily have the capacity to do a lot of the data processing and analysis. We can help our partners out. We can let the bigger entities help to do some of the heavy lifting, and then we can share the data sets across the region with everybody. Of course, another big benefit is consistency. We can do apples to apples comparisons over time because we're following similar protocols and specs in each cycle. And we don't have jurisdictional boundary issues anymore. When I want to look across a boundary, because it's a single consistent data set, I can look from city to county or city to city across the region and see everything in the same, apples to apples comparisons. So lots of benefits, and then derived products. And let me bring that sort of to the LiDAR piece. So in 2014, we did our first LiDAR collection as part of Lariac. It was done through a broad agency agreement with USGS, which is, I think, how most folks probably do this, or many. And it was QL2 data that you heard about in the prior talk from Mark. That was our first countywide LiDAR data collection that was consistently established across the region. And we developed a lot of the, what I'll call the common products, surface models, elevation models, terrain models, heights, contours, and so on. And that, as a QL2 data set, that was very good at the time, certainly what we could afford across the consortium to give us a good understanding of our countywide landscape. So as we're looking forward to Lariac 7, we're going through the planning process now. We're already have 39 of our partners on board with letters of intent or signed participant agreements, and are looking at an internal budget, I'll say, because a broad area agency agreement with USGS would bring additional resources to the pot, and some additional partners could bring additional resources on the LiDAR side to the pot. We're looking at a budget of somewhere around $4.25 million for our imagery, our LiDAR, and our derived product components of Lariac 7. The way we do this functionally is we have a technical advisory group. So that's a group representing not all of our participants, but representative participants from cities, from other agencies, from universities, and from the county. That group reviews what we've done in the past, what we'd like to do looking forward, and then sort of determines where we're going to maybe maintain the same specifications and standards, or where we may change them. And of course, in the case of LiDAR, our primary change from 2014 to 2023 is going from a QL2 collection to a QL1 collection, getting a higher point density and a more detailed point cloud from which to derive all those great products you saw in the last two presentations. And we're working on scopes of work, at this point, to start preparing for those paperwork processes and bidding processes as appropriate. The other thing that's interesting on the second LiDAR acquisition, and I think Nate kind of indirectly alluded to the Northern California collections that have been going on, is we're looking at partnering with the folks at UC San Diego and the Alert Wildfire program to build not just an LA County partnership in Lariac, but a broader consortium that includes essentially all the southern coastal counties of California. So the shaded area you see here, just to give you an idea, that's what Alert Wildfire is looking at doing for their LiDAR collections in conjunction with USGS and other partners. And you can see here in the zoomed in part, the pink areas are not covered by that. The yellow areas are covered by that. So I've been in discussions, and I would encourage others in this piece of the map to join us. We're looking at, can we bring county or local government resources together with the Alert Wildfire resources and the USGS to do a larger collection that will be consistent, not just in LA County, but across the entire South Coast. And I think that's going to be a great opportunity, again, to even build out better benefits of leveraging money and resources and getting derived products. So just to kind of wrap this up, because I know we're already behind schedule, I think a few things that are really important to take away from these ideas of consortia and building partnerships and bringing resources together are Lariac's been very successful. As I said, we're saving money, we're getting high quality products, we've got built these partnerships and shared learning and resources. And through its history, it's been a sufficiently exciting model to others around the country that now there are similar consortia that have developed over the last decade or so all over the country that sort of follow the Lariac model. And as I said, we're looking to extend that specifically in the LiDAR space to work with our partners in adjacent counties up and down the coast. As we know, things like fires, floods, and other things don't respect our jurisdictional boundaries. And we saw that very clearly when we had the Woolsey fire down here on the LA County, Ventura County border. Our data didn't line up. We were great within, but not across. So building those larger collaborations really can pay off in the data and the analysis and the products. And most importantly, it does save a lot of our resources. We can put more money into the pot collectively to get more derived products, more high quality products than we could individually. So with that, I'm going to stop. I will say, if you want to learn more about Lariac, you can visit our county website, gis.lacounty.gov, and there is a Lariac link in the menu bar at the top where there are an immense number of resources on the history of the program, the partnership agreement templates, and other things. And of course, I'm happy to chat with folks if you'd like to learn more. My email's there as well. So with that, I will stop. Thank you.
Thanks so much, Steve. And opportunities already identified for potential discussion in the region group later today. So we'll turn it back to Mark Tuckman to talk about what he has been involved in with collaborations in the North State and Bay Area. Go ahead, Mark.
Thanks, Ariel. Thanks, Steve. It's great to see your presentation, Steve. We're on parallel tracks up here, and we have been working for the last, 8 or so years with different consortia in the Bay Area to create LiDAR data sets and fine scale veg mapping products across much of the Bay Area. So starting with Sonoma County in 2012 or so, and then going through the present day, we've got, we're in the process or have produced the fine scale vegetation maps and a sort of a stack of landscape mapping and LiDAR derivatives for Marin, Sonoma, San Mateo, Santa Cruz and Santa Clara County, and now starting to the project, which is funded in Alameda and Contra Costa counties. And each one of these products requires and sort of starts with LiDAR data and the production of a set of LiDAR derivatives. The common products kind of that's Steve referred to at least, and then usually additional products as well, depending on the county. Here an example of those products that are coming out of these projects for each county. And I showed a number of these examples in my talk earlier on. So again, this work began at Sonoma County, who kind of had a vision for a fine scale veg map in 2012 or so, and we sat down with them and all agreed we need LiDAR, and so that became the beginning of our LiDAR sort of work, and then did the work in Sonoma to create the vegetation maps, the LiDAR derivatives, and other map products like impervious surfaces, and then did the same thing led by the Golden Gate National Parks Conservancy and OneTam in Marin and San Mateo counties, parts of San Francisco County, and then are kind of finishing up projects now in Santa Cruz and Santa Clara County, similar projects that are again, another consortium led by the San Mateo Resource Conservation District, Golden Gate Parks Conservancy, and a long list of others. And now starting in Alameda and Contra Costa counties as well. And the great thing about these projects is that they result in landscape data sets that are high resolution enough to support sort of parcel-based management decisions. And that's kind of what the need was in starting in Sonoma, where I live and work. And it's been, it's been great to be able to produce these data sets. And this is very similar to Steve's slide on benefits. And I think Steve's list was probably more comprehensive, but the idea of, having a consortium, and each consortium is different depending on the county that we're working in, but having, lowering each organization's cost by sharing costs across all the consortium members, and managing the project.
Mark,
Yeah.
It looks like we're just seeing a blank slide that says LiDAR use case examples at the top.
Oh, no. Okay.
Yeah. So I was thinking you were. Yeah.
Let me do something about that. Just a second. How's that?
Looks good.
That? Okay. So yeah, sorry that I was scrolling on my side, but I guess it wasn't scrolling on your side. So just to again reiterate the map of the Bay Area, and the work that we're doing is kind of creeping across the Bay Area now, and almost complete for most of the Bay Area. Just a visual of the data products again that we're producing, those common data products, but then more advanced derivative products like the vegetation maps, the fuel products, the impervious surfaces, and just the timeline that I was going through. We can keep moving here, but now back to the benefits that these consortia really provide. The economy of scale can't be overstated. Doing this work at scale and for as big a region as you can lowers the cost of data processing, lowers the cost of producing all the derivative products and the maps, and it allows for the ability to work with the data across boundaries, as Steve mentioned. Again, each consortium has been totally different and has different goals and members, but they all share this inclusion of local, county, state, federal, private, and NGO partners. And we've had great support from especially on the LiDAR side, from the USGS, from Carol Ostegren, and also in Sonoma County from NASA. And having this ownership, having this disparate group of stakeholders really builds this broad ownership, and it fosters new partnerships. One of the things that we've done and really been emphatic about doing is making data products public. So when we produce a LiDAR derivative, when we produce a veg map, any data product, we make it available in as many ways as we can on ArcGIS Online, as for download in other places as well, and make it available. In Sonoma, we had a website, sonomavegmap.org. More recently, for the rest of the broader Bay Area work, we're pushing everything that we produce up to pacificvegmap.org. And it's available as, if it's a raster, as a TIFF for download. If it's a vector, as a service on ArcGIS Online. There's data sheets for everything, and metadata and reports. So we're kind of standardizing the distribution and accessibility of the data sets across the region and making everything public. The last thing I want to talk about, this is an exciting new development. So this map shows the green areas show the North Coast, the areas of the North Coast that don't have LiDAR data. Sonoma County actually does, but it's old now, and much of the county is burned. So these green areas were, areas targeted for new LiDAR, and the North Coast Resource Partnership put in a grant with USGS to collect new LiDAR across this huge geography. It's about 12 million acres. USGS granted the award to the NCRP, and so this project will fill this large gap. It's really exciting for us folks who are doing a lot of work in the North Coast, and the co-funders that NCRP worked with were, besides USGS, were the Department of Conservation, DOC, Sonoma Ag and Open Space, the Water Agency in Sonoma County, Humboldt Bay Municipal Utility District, and then UC San Diego. So really great news. This should be happening in the next several months. So that's, oh no, I do have more to show here real quick. We did in Sonoma County, after the project was pretty much complete, Cass Green did a survey of LiDAR users, the folks who were using the data in Sonoma County. And I think there was about 100 responses to the survey, and Cass did a nice report and summarized, who's using the LiDAR data and the derivative products, and found that really it's an across the board use in the county. It's not just agencies and RCDs and nonprofits and the government agencies. It's commercial folks managing land for ranchers or vineyard managers. So really widely used, the data products. And then what are they using them for? Again, it's like many different things. Look at all these applications: flood management, engineering, planning, and design. 10% of the folks are using the LiDAR for pre-planning, disaster response, ag, outreach and education, environmental and conservation planning, urban planning, watershed management, and forest management. So really across the board uses. And then just some testimonials of what people say about these data. Folks, land managers who didn't have LiDAR and LiDAR derivatives until now. It's like stumbling into King Tut's tomb. So yeah, really, really nice feedback from people, and it's great to see people using these data. That's all I had. I want to sign it off here to
Thanks, Mark.
Sure.
Thanks so much, everyone. Those were great presentations. So we're shifting now from our backgrounding stage to more active involvement from folks. So the first piece we would like to show for you is we're going to do an in-meeting poll, and it's about which breakout groups you all would like to go to. So I'm going to just share my screen once again, and our first breakout session. Can everybody see my slide?
Yes.
Great. Will be topic based. So y'all will be choosing a breakout based on a particular topic. And we had to slice and dice things. So we did an initial pre-survey, and it looked like a lot of folks might be interested in infrastructure and urban uses. So we've split things up. So I'm sorry for all these words, but please look for your area of interest. We have urban uses and infrastructure, and we put sort of cultural, archaeological in with there, and you can see the list there of we're sort of roughly cutting things up, sort of urban construction and transportation, buildings, and then we have non-urban infrastructure and uses, and that might be utility grids, transportation corridors, energy-based, and sort of non-urban subsidence, drainage, and construction. So then number 3 is any geology or geologic hazards based uses in areas, including disasters, tsunamis, earthquakes, landslides. Number 4, coastal management, anything related to sea level rise, offshore energy, or near and offshore bathymetry. So we're also looking at potentially related data like bathymetry that's not necessarily LiDAR. Then number 5, water supply, quality, and groundwater recharge. Number 6, hydrology, which would include flooding, inland bathymetry, and hydrological connectivity. Number 7, landscape health and management related to more extractive use like agriculture, grazing, timber, biomass. And then last one, so there are 8 breakout groups for topics altogether, is veg, biodiversity, habitat, carbon sequestration, and wildland fire. So we're going to do a survey that has 2 questions. The first question is what topic group you'd like to choose. And once we get your information, it's going to help us figure out if we have enough folks and if we have to consolidate things. So the second set of breakouts will be based on regions. So Southern California, Central Valley, Sierra Nevada, Bay Area, and North Central Coast, and the North State, which would include North Coast, Southern Cascades, Shasta Valley, Modoc Plateau, and then statewide. And there are a lot of state and federal folks here today. I'm going to really actively encourage you, if you can, to choose one of the regional areas to help and support folks get these regional collaborative thinking and efforts going, and support folks at that level if you can. We will have one statewide, but we're hoping that more of the state and federal folks can support the regional folks. So with that, we are ready to give you the polls to choose your breakouts. And obviously 1 per question only.
See a question in chat, someone interested in subsidence. Was that part of your list, Ariel?
Yes, thank you.
That?
And so subsidence could go into a number of different areas. It could go into non-urban use and infrastructure. It could go into geology and geologic hazards. I'm going to ask you to think about the folks you might want to be having a collaborative conversation with, and you know where you might best want to have a conversation with folks. If it's also close to the bay or ocean, it could be, you know, coastal management related. So it kind of, these are rough. Please, you know, this is not a test. This is just where you want to gather and have a conversation. So, okay. So Amanda, is that poll done? Or am I just
Looks
not
like,
seeing it because?
Oh, sorry. 50 people have responded.
Okay.
It should have popped up for you. I have someone asking me if they're missing it. It should have popped up within Zoom.
You know what? If somebody does not see the poll, please, if you can, we've shown you the slides. Can you put in the chat what your preferences are, and we will fold that into our data. This is so we can make sure we have support for where folks want to go. And thanks that people are putting their selections in chat if they didn't see the poll. Is there anybody else? Raise your hand if you still need to finish the poll. I think we're good to go.
All right, I'm going to go ahead and end the poll, and then I can just share. There's a couple that didn't get a ton of responses. So
Amanda,
looking
this
at
is
topics
something we could probably work on offline if
Yep.
folks have their choices. Does that make sense?
Great. I will stop sharing that, and you can go
Yeah.
ahead and move forward.
Thanks, because that's sort of for our logistical support piece. I'm now going to turn it over to Jason Lally with the Government Operations Agency, who's going to be doing our in-meeting survey on what your challenges are, what's driving you to your interest in using LiDAR, which is going to help to give information for you all to be working through and talking about in your breakout groups. Go ahead, Jason.
Ariel, when I get to it, will you be able to drop the links in?
Yes, thank you.
Okay. I won't, we don't need them now yet. Good morning, everyone. Thank you for the introduction. I'm Jason Lally with the Government Operations Agency. I'm the Deputy Chief Data Officer. And I'm just going to help out with this little piece here. I'm going to give a quick end-to-end overview, and then we'll go in and we'll kind of take the polls one at a time. So I'll actually show you how you enter. So please pay close attention. They're not really hard, but just want to make sure that everyone gets the same information. So the purpose of this is to generate a number of challenge statements you think LiDAR Derived data could help you with. So you being you, your organization, your community, whoever you is for you. The one thing I want to note here, and we'll put up a couple of example challenge statements. This is not a quiz. So we're not looking for you to know exactly if your challenge can be solved by LiDAR. You might have a guess at it. That's okay. It's really like things that are on top of your mind. You don't have to know about LiDAR or what the derived products can do. But if you have a good sense of it, we want those challenges. And then we'll use those generated statements as reference and inspiration during the breakout sessions that Ariel was just taking a poll on. So quick orientation, it's two simple forms. The links are coming later. There's a participant form on your right, and it's your name, email, organization. We're all going to fill that out, take like a minute. The reason we fill that out is that over here on the brainstorm challenges, you can select your email address really quickly, and I'll show you what that looks like, but that just allows us to kind of link those things together. We won't be sharing the who issued each of the brainstorm challenges to anyone without any kind of opt-in. It'll just be used for the workshop setting in the background. So this is just so that we can kind of track who is in the meeting and what follow-up we can do. And then what that does is all of this is going into a sort of background table, and that's what you'll have access to. You'll be able to see these live, and I'll just pull it up real quick. It's going to be empty this time because those were just test topics, but this will fill up with those brainstorm ideas as you enter them.
And can I just check, make sure folks can see these? Get a thumbs up.
Yes, can see him.
Great, thanks. Sorry, go ahead, Jason.
So I'll be populating that. You don't have to worry about that now. I just want you to see the whole picture before we get into it. So let's do the first one, and I'm going to first fill it out, and then Ariel will drop this in. So this,
Jason, I'm apologizing. I'm having trouble finding the links.
Oh, that's okay. I got them over here.
Great.
Okay. So I'll drop that in right after this. So real simple, my name and my email, organization, and then region that I work in, area, and just submit that, and we're done. So that's the first part, and I'm gonna. Oh, you got it?
Got it.
Okay.
Sorry.
So Ariel's going to drop that in.
And
So
that
go
is the
ahead.
participant form.
Yep, the participant form. I'll put it again. So I just dropped it an Ariel as well. Go ahead and click on that and then quickly fill that out. We'll give it about a minute or two. Great, I see them coming in. And again, the link is in the chat. You just go to that participant form, fill out name, email, organization, region. Joseph Thomas, it keeps blanking on me when I try to change fields. It shouldn't, but if you do have another browser, I don't know if you're on Firefox or Edge or Chrome or something, but might want to try a different browser.
Yeah, Firefox has worked for me.
There's still some coming in. I'm going to let people continue to fill that out and get on to the brainstorming form.
Okay. There we go. Brainstorm form.
Don't fill it out yet. Well, I mean, you can if you could, but I'll walk through it. So, basically here, you're going to select your email address. So what I just did there is you can add and you can quickly search for your email. And then you're going to put in a challenge statement. And these are just things like as simple as identifying abandoned landmines, or not landmines, abandoned mines to ensure safety of people, mapping areas prone to flooding after storm events to prioritize post-fire mitigations, tracking growth of restored salt marsh habitat. So some kind of challenge that you think LiDAR can support. You don't have to know how it would support, you don't have to write that, just what's a challenge you or your organization is facing. So there's that. So I'm gonna just quickly grab one of those. So I'm putting it in there. And then you're gonna categorize that challenge into a primary topic. So in this case, I put the flooding. So I'm gonna do wildland fire in this case. And again, this isn't a quiz. So you might say, oh, that's flooding, that is water. But for me, I want this for post-fire mitigation. So I'm going to put wildland fire. In what regions? I'm just going to make this up. And then if you think you know derived products that could help with this, you can select them, but this is optional. And then you submit. And then if we want you to submit as many challenges as possible, so go ahead and you can click submit another response, and you can go ahead and enter another challenge statement, categorize it, and just do as many as you'd like. And again, that form, and this is all in Airtable, yes. And what I'm going to do, just in case, is I'm going to make that email address part at the top optional in case people had problems entering in the participant form for time's sake. So if you couldn't get your stuff in the participant form, just go ahead and fill out challenges. And here they are coming in. I don't want to distract people, but I'll just let you know that they are coming in. About 33. About another minute. They're still coming in. Folks can continue brainstorming. Just a couple of things here. We got quite a number of folks in geology and geologic hazards, 11 different brainstorming challenge statements. Has had a lot of infrastructure, not surprising based on breakouts, and around landscape health, both in terms of vegetation and wildfire. Some additional others. But this is, yeah, so we have, and things are still coming in over there. So what, you can continue brainstorming, I think. And what do you think, Ariel? Do you want?
Why don't I
Switch over, or because they're
sure.
They are still coming in.
Okay, well, why don't shall I give directions and people can maybe be bifurcating their attention a little bit. So I am going to stop your screen sharing, Jason. That okay? Yeah, great. Okay. Just to orient you all to, everybody can see my screen. the mural board and our breakout sessions, we are going to give you specific links in your breakouts that will take you to your focused workspace. We're looking at something like 8 breakouts the first session and 6 or more in the second. So just to orient you, we have our topical breakout sessions on the left, but you'll be brought into one of these squares. And then our second session, the regions, on the right. And your workspace will look like this. This happens to be just one, but these are duplicated. So your workspace there are 2 different questions for each breakout session. So there are boxes for each question on the top. On the lower left is a participants square. And the idea is when you join your breakout, you can double click on that and create your sticky to record that you are in that breakout. And then there's information that you all have about yourselves to share with each other. And then you all will be choosing someone, or someone will volunteer to be a note taker for that group to track your verbal discussions, right? And so the bottom right is for, there's a text box in there for the note taker to handily start taking notes. So at the top, basically you will be self-running your breakout groups. We will have a LiDAR team member, at least one LiDAR team member there as a liaison to help support you. And that LiDAR team member will be bringing more specific instructions and important links for the group. But the group will choose their facilitator. They will choose a note taker, a timekeeper. That's just somebody to remind you, like, oh, we've got this many more minutes. And for the second regional sessions, only a reporter who will come back out into plenary and briefly type into chat, you know, some of the key take homes from your conversation. So those, this list of roles is up at the top in bright yellow. So for breakout session number 1, basically the breakouts are going to be pretty similar. You're going to gather, you're going to, you know, identify yourself in that participants box. You'll choose your roles, and then you all will have about 10 minutes to look over the data that you all are just generating right now with the challenge surveys, so that you can get a sense of what others' interests are, where commonalities might exist. And then we have the 2 questions to go through. And for breakout session 1, you're meeting by topics. And these are questions to get you started. Feel free, if you have other topics of interest, to go where you're comfortable. But basically, after you've checked through the results, where are there similar or common interests? What common ground might exist for you all as far as what you'd like to be focusing on? And then the second question is about success stories. In this topic area, do we know of successful LiDAR projects or collaborations or efforts that are that this group could be building on for this topic? Or what ideas, resources, or tips do you all have to share about what sort of, you know, what would be a successful collaboration or successfully generating LiDAR derived products for this topic? With that, that is the our backgrounding for you all. And Jason, I just wanted to check, are people still generating challenge statements, or we're good on that?
I think we're good. Yeah, it seems to settled.
Okay, great. Well, Amanda is here and she is going to launch us into breakouts.
Ariel, did you want me? Oh, too late.
Excuse
Go
me,
ahead, Debbie.
Oh,
On the
okay.
vendor.
Yes, thank you.
Yeah, sorry. Just quickly, one thing that I had intended to say in the opening, but thought was more appropriate before we break out into breakout groups is, first off, thank you so much for all of the support and interest that we've received in this effort from the vendor community, we have not successfully plumbed the depths of that opportunity. But also, I wanted to say that the focus of this really is on connecting data users and policy folks. So as you participate in the breakouts, if you could really, vendor folks, if you could really focus your comments and your participation on helping to cultivate that collaborative space, we would very much appreciate that. Amanda, now you can launch us all off.
Great. I'm going to open up the rooms, and due to the survey interest, we're going to have urban use and infrastructure, geology, coastal management, water supply, hydrology, and then we're going to combine non-urban and landscape for ag, timber, and biomass. So let me go ahead and open these. And you're going to go ahead and select a room. If you cannot move yourself into a room, go ahead and message me and I will move you into one. We go.
No consent that I saw. Welcome back, everyone. So this is an opportunity, if people want to add to their chat report outs for the group, what they found helpful or valuable from their discussions that they thought you think is worth sharing or reporting out. Some of you may have chosen a reporter who's already doing that, but feel free to share what that experience was like, what was helpful, or what else came up as far as your needs. And while we're doing that, I'm just going to share my screen. Just acknowledge all of the work that you've done. We have quite a lot of data on the board, and we will be exporting that data along with the data table. And wondering, Jason, you may have that handy. I can also just, I've got them actually. I'm going to type in once again the participant form and the brainstorm form. So if there are additional ideas or challenges that you would like to add to or fill out, we've got those links available. We will be getting a post-meeting survey to you. And one of the things that we'll be asking you is, are you comfortable in sharing out this data with, your name, email as a support tool for building collaborations? And obviously also just how this went for you, what worked, what you'd like to see being done differently, how the consortium can continue to support your efforts towards collaboration. And David Harris, you also, did you have an invitation you wanted to offer?
Not particularly. But you didn't...
Okay. Yeah, so at a certain point, there may be some use case development that might be ripe for the group to be offering. And with that, I will turn it over to Debbie to offer some final thoughts.
Thank you, Ariel. And my first final thought is a very big thank you to Ariel and Amanda, who have just organized us all in fine fashion, and also to the LiDAR team and Jason, who put together the Airtable and provided the support on that. I was trying to quickly reflect on that. I feel like that was a hit and run. There was a lot of information. Both of the breakouts felt too short. so thank you all for sticking with it and providing that information. It seems like there might be some more conversations that we all could have moving forward. And if you have suggestions about that, please don't hesitate to email those or to make note of them in the survey that reflecting on the process. Definitely heard some consternation about moving from frame to, from across 3 different platforms. So maybe next time we'll figure out how to avoid that. And thank you to everyone who volunteered to be a facilitator, timekeeper, etc. I know it was an on-the-fly thing, and just thank you for taking that risk with us. And thank you all for all the great work that you do in the LiDAR community. And Amanda, not Amanda, sorry, Tara is clapping. That's awesome. Thank you. I thought it was a hand up. Ariel or Amanda, is there any last thing, or anyone else have any last thought they'd like to offer?
Yeah, I just want to invite the team members, any last thought you'd like to offer.
I'd like to thank everybody for the incredibly productive conversation. We've touched on a huge number of opportunities to add value, and we really look forward to developing those with you going forward.
Thanks, David.
Yeah, and I just wanted to add my thanks for joining in and sharing with us. We're building a much more complete understanding of the breadth of interest in these data across a great many subject areas and sets of stakeholders. It's really both gratifying to see and helping contribute to thinking about how we can help this all move forward.
Thanks, everyone. Thanks for your participation and your active participation today.
This is Kelly from Cal Fire again. I just want to really thank you for having this forum. LiDAR is really exciting, but we need to figure out how to deal with it. How to store it, how to process it. So I really appreciate this. Thank you.
Great, thanks. And for Kelly and others, yeah, we look forward to hearing, how we can best support you all in grappling with all of that.
Thanks, Carol.
You're welcome, Brian.
All right. I like the personal thank yous too. All right, well, we are at time, so stay tuned. There's lots to come, and everyone have a great afternoon.
Thank you. Thanks for putting us on.